In this video, we are going to look at how FastAPI connects to a real SQL database using SQLModel, a library that sits on top of SQLAlchemy and Pydantic at the same time. By the end, you will know how to define a table, wire up a database session as a dependency, and write clean type-safe endpoints that read and write rows. Here is the pain. When you add a database to a FastAPI app the traditional way, you end up writing your data structure twice. Once as an SQLAlchemy mapped class, so the ORM can read and write rows, and again as a Pydantic model so FastAPI can validate request bodies. Every time you add a field, you must remember to update both, and if you miss one, you get a bug that is hard to trace. On top of that, you have to manage database sessions carefully so they open before a request and close after, without leaking connections. Imagine an architect who hands the same document to the construction crew and the building inspector. The crew uses it to put up the walls. The inspector uses it to check they are correct. SQLModel works the same way. You write one class, and it simultaneously tells SQLAlchemy how to create the database table, and tells Pydantic how to validate incoming and outgoing JSON. One source of truth. No duplication. SQLModel gives you 4 things to keep straight. First, the model class itself, which inherits from SQLModel with table equals true, making it both a Pydantic schema and an SQLAlchemy table at the same time. Second, the engine which you create once at startup and reuse across all requests. It holds your connection pool. Third, the session, a short-lived object that tracks changes for one unit of work, typically one HTTP request. Fourth, a yield dependency that opens a session before your path function runs and closes it cleanly after the response is sent. Let me walk through this from top to bottom. The hero class inherits from SQLModel with table equals true. That single flag tells SQLModel to register this class as an SQLAlchemy table and keep Pydantic validation active. The head field has a default of none and is marked as the primary key, so the database generates it automatically. Next, we call create_engine once with the SQLite URL. This is your app-wide connection pool, created one time and reused. The get_session function is our yield dependency. It opens a session using a context manager, yields it into the path function, and the context manager closes it when the request finishes, even if an exception is raised. In create_hero, FastAPI uses the hero class to validate the incoming JSON body, then session.add stages the new row, session.commit writes it, and session.refresh pulls the auto-generated ID back into the object so we can return it. In read_heroes, session.exec runs a SQLModel select statement, and .all returns every row as a list of hero instances. Here is the sequence every request follows. FastAPI sees that your path function depends on get_session, so it calls that generator first. The with session block opens a connection from the pool and yields the session object into your function. Your function does its database work, adding rows, running queries, and returns a result. FastAPI serializes the response and sends it to the client. Only then does execution continue past the yield back in get_session, where the context manager commits or rolls back and releases the connection. The key consequence is that sessions never outlive a single request, so you never leak open transactions. SQLModel shines on greenfield FastAPI projects where you control the schema and want a single source of truth for your data shapes. The unified model means less boilerplate and automatic open API docs that match what actually goes into the database. But if your project already has a separate SQLAlchemy layer with hand-tuned models, merging them into SQLModel is more pain than gain. Also be aware that SQLModel's async support is still maturing. If you need true async database access at scale, you may be better served by SQLAlchemy's async session directly or a purpose-built async ORM. To wrap up, SQLModel's big idea is eliminating the duplicate model problem by making one class serve both the ORM and the validator. The engine is created once at startup and shared everywhere. The session is created fresh for each request through a yield dependency, so cleanup is guaranteed. Keep in mind that this unified approach works best on new projects. If you already have a mature SQLAlchemy setup or you need fully async database access, you should evaluate whether SQLModel's current limitations are acceptable before committing to it.